Every time you open an app, a system sifts through billions of options in milliseconds to find the exact piece of content that will keep you scrolling. It feels like magic, or like the app is secretly listening to your microphone, but it is actually just a series of incredibly fast, ruthless mathematical filters. We will start by looking at how platforms turn your human behavior into raw math, explore the clever tricks they use to group you with millions of strangers, trace the multi-step funnel that narrows billions of posts down to just one feed, and end on how these systems are evolving to fix their own flaws. At its heart, a recommendation algorithm has only one real job: predicting the immediate future. When you open an app, the system calculates a highly precise probability score for every piece of content available to you. It is trying to guess the exact percentage chance that you will click, watch, like, or buy a specific item right now in this exact moment. To make these predictions, the algorithm needs data, which comes in two distinct flavors: explicit and implicit. Explicit data is what you actively tell the system, like hitting the thumbs up button, leaving a 5-star review, or subscribing to a channel. But implicit data is what you actually do, like how long your screen pauses on a photo, or whether you turn the volume up on a video. Engineers quickly learned that implicit data is vastly more powerful, because what people say they like is rarely what actually holds their attention. The oldest and simplest way to recommend something is called content-based filtering. If you watch a lot of fast-paced science fiction movies, the system simply looks at the tags, genres, and actors of those movies and finds other films with the exact same labels. It works well enough for simple tasks, but it has a massive flaw. It traps you in a bubble, almost never showing you anything surprising or outside your established tastes. To break out of that bubble, platforms developed collaborative filtering, which ignores the actual content of the video entirely and focuses on the community instead. Two strangers living halfway across the world might happen to like the exact same obscure indie bands. When one of them suddenly starts listening to a brand new artist, the algorithm immediately pushes that track to the other person, assuming their underlying tastes are deeply linked. To make collaborative filtering work, the system builds a gigantic, invisible grid called a user item matrix. This structure works exactly like a massive spreadsheet, assigning a dedicated row to every single user on Earth and a column to every single video on the platform. At the exact intersection where your row meets a video's column, the system records a numerical score representing how much you liked it. But there is an immediate, glaring issue with this giant spreadsheet, which engineers call the sparsity problem. Because a platform might have billions of videos and you have only watched a few thousand in your lifetime, 99% of your row is completely blank. The algorithm cannot effectively do math on millions of empty spaces, so it has to figure out a way to compress this massive, mostly empty grid into something smaller and more dense. The historical solution to this empty space was a mathematical technique called matrix factorization. The system breaks the giant grid down into two smaller, denser grids, looking for hidden patterns that connect users and items. It might discover a hidden mathematical connection that loosely translates to slapstick humor or relaxing acoustic music without the machine ever actually understanding what those human concepts are. Today, modern artificial intelligence has taken this concept even further, using a technology called embeddings. An embedding is a way of translating a video, a product, or even your entire human user profile into a specific coordinate in a high-dimensional mathematical space. If two videos have similar vibes or appeal to similar people, their coordinates will literally be placed close together on this invisible, multi-dimensional map. Once everything is mapped out as coordinates, recommending content becomes a simple matter of measuring physical distance in that digital space. The algorithm looks at where your personal user coordinate sits on this giant map and draws a tight circle around it. The videos that are physically closest to your dot on the map are the ones most likely to end up on your screen. However, calculating the exact distance between your coordinate and billions of video coordinates every single time you refresh your feed would require an impossible amount of computing power. A server simply cannot do a billion complex math equations in the 300 milliseconds it takes your app to load. To bypass this speed limit, large platforms break the recommendation process into a multi-step pipeline called a funnel. The first stage of the funnel is candidate generation, where the goal is to be incredibly fast, even if the matches are a little sloppy. The system uses lightweight rules to quickly grab a few hundred videos out of the billions available. It might blindly pull 50 videos from creators you subscribe to, 50 from your geographic area, and 100 that are currently trending in your favorite categories. Now that the pool is narrowed down to just a few hundred candidates, the algorithm can afford to bring in the heavy machinery. This second stage is called ranking, where a massive neural network intensely scrutinizes those remaining videos. It calculates complex interactions, like whether you prefer long videos on your television at night, but short videos on your phone during your morning commute, and assigns a highly precise score to each one. Before those top scoring videos actually hit your screen, they pass through a final stage called re-ranking. This is where human-designed business rules step in to override the pure machine learning math. The system will shuffle the final order so you do not see 10 identical videos in a row, filter out known spam, and ensure there is a healthy mix of photos, text, and video. Even with this incredibly complex pipeline running perfectly, engineers still face a major hurdle known as the cold start problem. When a brand new creator uploads a video, it has 0 views, 0 clicks, and 0 historical data, which means the algorithm has no idea where to put its coordinate on the map. Without any data to fuel the mathematical filters, new content risks remaining completely invisible forever. To give new videos a chance, platforms borrow a concept from probability theory called explore and exploit. The algorithm will exploit its knowledge by filling most of your feed with guaranteed hits that it knows will keep you engaged. But it purposefully dedicates a small fraction of your screen to explore new, untested content, sacrificing a little bit of guaranteed engagement just to gather data on fresh uploads. For years, these algorithms only cared about predicting the very next click, which inevitably led to feeds completely overwhelmed by sensational clickbait. Today, advanced systems use reinforcement learning to look at the big picture, treating your attention like a long-term chess game. Instead of just getting you to tap a single thumbnail, they calculate a whole sequence of recommendations designed to maximize the total time you spend in the app over an entire month. But this relentless optimization for engagement brings us to a massive, unintended consequence of the modern internet. The algorithms quickly learned that human beings engage most deeply and predictably with content that sparks outrage, tribalism, or deep anxiety. The machine does not know what anger actually is. It just knows that certain mathematical patterns of pixels keep you from closing the app, leading to radicalized filter bubbles and endless doom scrolling. The frontier of recommendation technology is now entirely about escaping the very engagement traps these systems created over the last decade. Engineers are actively trying to optimize for long-term user satisfaction and digital well-being, using large language models to understand the actual nuanced meaning inside a video rather than just blindly chasing user clicks. As the artificial intelligence gets better at understanding context, the algorithms will hopefully shift from showing us what we cannot look away from to showing us what we actually value. If you enjoyed this deep dive, please take a moment to like the video, subscribe to the channel, and let me know your thoughts in the comments below.